Let's cover index rebuilds versus index reorganize. Index reorganizes. This is one of those things where some people spend a lot of time working on, and it can definitely benefit what you do, but on the flip side, it can be busy work that doesn't actually get anything done. A good example of why I think that is, think about a very high OLTP table that data are constantly coming in and out of, okay? And we're talking about, let's say, 1,000,000 records a second is coming in and 1,000,000 records a second is coming out. What would be your index rebuild strategy for such a table, okay? So some environments, you really don't have to worry about it as much as other environments, right? And that's one of the things to consider right off the bat is, are we talking about an OLAP environment? Are we talking about an OLTP environment? Are we talking about a mixed environment? And then, of course, even dropping down a further level, which is what are we looking at as far as our tables, right? What is the table? What is the table used for? And then how large is its size? Do you really want to build an index on a table that's used for a query once a year? I mean, like, why? Even if the data change, if you're using the query once a year, let's say it takes 1 minute, without an index at all, why would you worry about rebuilding or building an index in the first place if it only takes 1 minute? Okay. What are the indexes? I say what is or what are the indexes fragmentation level, right? I mean, if the fragmentation level is 5%, you don't need to rebuild or reorganize, right? Rebuilding, for the record, it drops the index and recreates it. Okay, that's what a rebuild is. It's a very heavy operation. You can sometimes, if you want, build a test environment and create an index on a huge table and look at the resources that are used. It's very resource intensive. Okay, so rebuilding an index, generally you don't want to do it on an index that isn't fragmented, and they'll say that the best practice recommendation is 30%. There are definitely DBAs, I think, and myself who think that maybe you can go higher than that, but it depends, again, on the environment. Okay, a reorganization, by contrast, is just physically reordering the leaf level pages. This is kind of like similar to how we read. We read, left to right when you read a page. That's how you're reading. Well, if I were to, reorder that, or if I were to mess that up to where you couldn't read that way on pages, then if I then reordered it, it would make it easier to read, right? Okay. And from the compaction standpoint, it does use whatever the fill factor settings are. But the difference with reorganizing from a resource perspective is it doesn't use quite as much, so it's much less intensive. So that's why if you don't have a lot of fragmentation, you don't want to blow your system out trying to rebuild an index when you don't need to rebuild it in the first place, okay? Another question to consider is how much offline time is available for this process and or application. Remember in the example that I gave at the beginning, which is 1,000,000 records come in a second and 1,000,000 records leave a second, or like a minute, let's say. I mean, if that is constantly happening throughout the day, or throughout the day and night and every point of every day, then offline time is not going to be available, right? And the other thing too is, would rebuilding an index or creating an index really even benefit a table which has that much data turnover that quickly, right? So, and then of course the other thing to consider is, how is your server built? Consider the fact that a lot of index rebuilds, they do use TempDB, or they may not use it, but if you haven't built TempDB right, that can create a headache there. So always think about your system. Where is the bottleneck going to form with each of these processes? If TempDB is it, then you may not want to use TempDB. If TempDB has a good capacity, you may be okay with using that. But consider where the bottlenecks are on your resources. A heavy OLTP environment, for my own self, for a heavy OLTP environment, I'm not going to have very many indexes, up to 0 indexes. There are some tables in my OLTP environments that I have no indexes at all. And there's no reason for it. The data turnover is so fast and so furious. No. It would waste more time putting indexes on there, and then of course they'd be so fragmented out. And by the way, you can do these tests. You can let's say simulate an OLTP system, a really heavy OLTP system, and look at the index, how quickly the index has become fragmented, and it's just amazing. So I will build minimal indexes in OLTP environment, whereas in an OLAP environment, there's going to be a lot more indexes and there's going to be a better maintenance schedule, assuming that, of course, there is some offline time. A great example is like the Hong Kong Stock Exchange is only open for certain hours and certain days, right? I mean, it's closed on holidays. Bitcoin, by contrast, is always open, never closes. It's always up, right? I mean, that's a completely different build for something handling Bitcoin versus something handling the Hong Kong stocks. So that's generally how I'll go about it. Everybody has their own best practices. Definitely look up some resources, but this should give you some pointers to start. What is a table used for is a big one. What is the table in general? How large is its size? And then, of course, what is the application in front of it, and what is the database being used for?